Hey, welcome back. It has been a while, and as you can see, new studio, and a lot has happened. GPT-OSS and GPT-5 have both came out. And with that, today I want to focus on the Harmony prompt format, which is the way messages have been trained in both GPT-5 and GPT-OSS. And it gives a lot about what's happening in the training and how the models work underneath. So today we're going to focus in on that, and it'll help you understand those models a little bit better, but it will also help you to understand how to prompt them a little bit better because you understand what's going on underneath the hood. Now, to get started with GPT-OSS, you can use something like Ollama. We're not going to focus on Ollama today, but I just want to show you how you can quickly get started with it. So you can just type in Ollama run GPT-OSS, and that will download the 20 billion parameter model. And once it's downloaded, you can ask questions. So I am going to say, tell me a joke about cheese. And then it's going to say, as you can kind of see, like all of the thinking and reasoning models, you see it starts with this thinking. We need to give a joke about cheese. So it's doing that chain of thought analysis. And then when it's done thinking, you see this done thinking there. And then eventually you get the final answer, which is why don't secret agents ever get into a cheese shop? Because they're always worried about being brunette. I don't get it. I don't get that joke. It's a terrible joke. But the key thing is here is there is a message format. Now, Ollama hides that from you, so we can't get to the underlying message format. But you can start to see a little bit of the structure, and that's what we're going to sort of dial in today. And that is, you've got this thinking piece here, thinking, done thinking, and then you've got the final answer. So remember that. And in GPT-OSS and GPT-5 world, they are what's known as channels. And I'll break down that message format in a second. But to make it a little bit clearer, we're going to get away from Ollama and we're going to start using the Hugging Face models and download from there. Now, I'm just going to run that on my machine. I'm using a MacBook Pro M3 Max, so I can run the models quite easily. If you don't have enough memory or GPU to run these, then maybe use something like Google Colab. And again, everything I'm showing you is going to work pretty easily with Google Colab. Now, as you can see, I'm in a folder called Harmony Record. There's nothing in there. Now, to get started, there's a few libraries you need to install, and that is going to be Transformers Torch and Accelerate. And again, you can just do that with apip install. And as you can see, that works. Now, I like running UV on my machine. It's just easier to manage my virtual environment. So I'm just going to do UV add Transformers Torch Accelerate, and that will install that within the virtual environment. But you can easily just do pip. And in fact, if you're using Google Colab, just do that. I'm going to create a new file, and it's going to be called infer.py. And then I am just going to open up VS Code on my machine, and then we are going to write some code to get started very, very quickly. Now, to get started with the GPT-OSS model, it's actually super, super simple. You just need to import from the Transformers library. So I'm going to do from Transformers import pipeline. Now, for easiness sake, I'm going to use the pipeline functionality of Hugging Face. It makes it nice and easy. Later on, we'll do a normal generate, but this will allow us to see a little bit of what's going on underneath the hood. So the model ID is going to be OpenAI GPT-OSS at 20B. If you want to go and see the details of that model or where it's downloaded, you can go to huggingface.co/OpenAI GPT-OSS 20B. And then if you open that up there's loads of cool information. It's worth actually looking at it. But most importantly, you can see in the files here, all of the model weights are available. The tokenizer settings are available. And then you've got things like the chat template, which we're going to cover later. So there's a lot of cool information for you to be able to explore. But more importantly, when I type in OpenAI GPT-OSS 20B, that is basically the Hugging Face address. So huggingface.co/ and then it's that model ID there. And you can use that for downloading anything else. So now that I've got that, I need to set up my pipeline. So I'm going to say pipe equals pipeline. And I am going to be using text generation. And then I'm going to set the model is going to be equal to my model ID, which I've just set here. And then these settings are pretty important at the moment. So in this case, we're going to set the data type, so torch D type. I'm going to set this to auto because it can automatically work out what type it's running it with. Now, if you're wondering why I'm setting this to D-type auto, D-type in this case is the underlying data type of the tensor. Now, in the case of the GPT-OSS models, they have made an optimization that the models that they've released by default are in a format called MXFP4. So basically, it is a quantized model, i.e. They've shrunk the model down so it can fit into memory a little bit better. Now, it's optimized to run on an NVIDIA 16 gig GPU card. Now, of course, if you're not running an NVIDIA card there, then it's going to need to download a different data type. So in this case, it's going to download the B. Now, in this case, because I'm running on a Mac, it's going to get the bfloat 16 weights of the model, so it's slightly bigger. It's a different quantization in that sense, so it won't fit in a 16 gig, and I'll need more memory. My Mac will handle this fine. It's something to be aware of. Again, when you're in Google Colab, again, if you're running the NVIDIA, it's going to be able to run that on MXFP4 as well. I'm not going to go into the details of this. Maybe I'll do a video on quantization at some point. But for easiness sake, rather than you trying to figure this out, it's easier just to set that to kind of auto, and then it will automatically select the right model type. I want this to automatically detect my device. So in this case, it's going to pick up that it's running on Metal MPS. Again, if you're running this in Colab, it's going to be able to automatically detect your GPU from there. So once we've done that, I want to be able to set my messages, and again, it's just a list of these roles. Now, you'll be familiar with this kind of style for setting conversation. So I'm going to set a role, and in this case, the role is going to be a user. And then I'm going to say my content, or the message that I want to send here, is going to be whatever I would have typed, say, in Olama. So in our earlier case, we had tell me a joke about cheese. So I'm going to put the exact same prompt within here. And then I'm going to close that off. Now, of course, I can build up, richer conversations. So I can have things like the system prompt using role system, etc. We're going to break into that and what that means from Harmony. But the key thing for you to realize at the moment is this format here, which is role, user, content, etc. It isn't what the model actually sees. This gets translated via the thing called the chat template into a tokenized format. And the tokenized format in the case of GPT-OSS and GPT-5 is the Harmony prompt format, which we're going to display today. So now that I've set my messages, all I'm going to do to get an output here is I'm going to say outputs is equal to pipe. And then I'm going to pass in the messages. And then I just need to say how many tokens I want to generate. So I could leave that open. I am going to say 1024. If I want to shorter messages, I could make it a small amount. But that is basically saying in the model, don't create any more than 1,000 tokens. And the reason I'm setting that is I don't want it to sort of, especially with these thinking and reasoning models, I don't want it to be thinking and generating tokens forever. So I just want to cut it off if it goes off in a kind of weird spiral. And then finally, we are just going to output the output from the model. So I'm going to say print output 0. And then I just want to capture the generated text. So we're just going to say, give me generated text. Now we're going to run the model. So I'm going to do a UV run infer.py. Again, if you're running this on Colab or if you've done a pip install, you would just run py. You would just run python infer.py. So as you can see here, exactly what I explained earlier. So there's a warning that says using MXFP4 quantized model requires a GPU. We will default to dequantizing the model to BF16. Exactly what I said earlier. OpenAI has released the model in a quantized state. And therefore, if you're not running an NVIDIA card, then it needs to get dequantized to BF16 to run. So as you see, that works. Again, that script will, if you haven't got the model downloaded from on your machine already, it will go off to Hugging Face and it will download it into the cache. And because I set the device map to being auto, again, it's detected that I'm running Apple Silicon, so it's going to run that with MPS there. So again, if we just look at this for a second, we start to see a little bit more of what's going on here. So in this case, I've got my role as the assistant. So this is the output that's came back. So it's saying role as assistant, content, and then analysis. Remember what I said about channels and how it was hiding things away when we were running Ollama? So when I run the Ollama version, for example, you see that thinking piece there. This isn't actually part of the Harmony format whatsoever. In Harmony, as I said earlier, it's using a channel called analysis. And so the first thing that I'm seeing here is this analysis piece here. And again, some of the tokens are being hid away from there. So we're going to bring up the tokens in a second so you can see the exact tokens that are being generated. And then it says user requests a joke about cheese, blah, blah, blah. And then you see the next part there, you see assistant. So it's changed its role. And then final, why did the cheese apply for a job? So the final part is the equivalent of down here, which is what you, the user, sees here. And then everything after analysis is the analysis channel. And that is the thinking piece. And in fact, there are 3 channels that both GPT-5 and GPT-OSS work with. As I said, is the analysis channel. And basically, this is where reasoning tokens go. This is the thinking part. It'll also include calls to internal calls, such as Python or browser. So GPT-OSS has 2 built-in tools, which is Python and browser. So if you need to do web searching or if you need to do maths and it needs to generate some Python code, then rather than doing function calling straight in, it can use some built-in tools. And then basically, it will perform those tool calls within this analysis channel, i.e. in the same thinking space. Another thing about the analysis channel you'll find is OpenAI recommends it shouldn't be shown to the user because it doesn't have the same safety filtering. Now, I'm going to go into that in a little bit more detail later on in the video. But basically that means is because they're using test time compute, so in order to get to the right answer, there's a lot of thinking that goes on in that analysis channel. And some of that isn't maybe safety aligned. So, and it's got some things that they wouldn't want to show to the users. So actually in this case, the recommendation, even if you're using GPT-OSS, is basically to kind of not show that to the end user. But again, this is the cool thing about an open source model is we can see underneath the hood and we can see what's actually being generated. There's another channel, I'm not going to go into in too much detail on this one, which is the commentary channel. That's where basically function calling happens. So whenever I do function calling, so any tools that are outside of built-in tools, so maybe if I'm doing something like MCP calls or built my own tools, then they would go in the commentary channel, similar to the analysis. And then finally is the final channel, and that's what the user sort of sees there. So they're the kind of 3 main channels. Now, again, if I come back here, even in this version, I am hiding away the tokens, right? So as I said before, this role assistant content, this is a sort of parsed version. This isn't what the user would see. And the reason that the user wouldn't see that is down to this thing called the chat template. So again, if I come into Hugging Face and I click on chat template.jinja, you can see it's this sort of templating language. And you see it's very, very complicated. But the key thing that's going on there is that this Jinja template will translate from that format, role, content, etc. into the underlying token. So if I look here, for example, you can see there that if I search for role, it's doing an if messages role is equal to developer or messages role is system, then it's going to set a developer message and then it's going to do a bit of looping around there. So underneath the hood here is doing translation. Again, if message role equals assistant, then it's going to do translation. And there you start to see, remember what I said about channels, channel analysis, message, etc. So it's doing this translation from the role format that we are typing in our Python role user content, and it's translating it into the tokenized form that the GPT-OSS or GPT-5 models need, this Harmony format. And then similarly, when it gets output from the models, it's getting in a tokenized form, and then it'll get translated back into kind of this format. So the chat template is hiding a bunch of things from you. So to handle that, one of the things that we can do is try and display the underlying tokens that get generated. So to do that, we are going to import the auto tokenizer. And then before the pipeline, I am going to basically load up the tokenizer, the thing that does the conversion, into part of my script. So we're going to have tokenizer is equal to auto tokenizer from pre-trained, and we pass in the model ID. And what happens there is it goes off to Hugging Face. It works out from the config what the tokenizer it should be using, downloads that tokenizer, and then we can start interacting and do tokenization ourselves. So now that I've got the tokenizer, if I want to, I can take the messages that we've set here, and then I can do a tokenizer.apply chat template, and I can pass in the messages. I'll set tokenize equals false, but I will add a generation prompt. Again, I'm not going to go into the details of this just now. I cover this in some of my other videos, but really all I want to be able to do is then print that chat input. And then similarly, what I want to be able to do is when I get the output, I want to be able to see the underlying tokens as well. So now what I'm going to do is reapply the chat template for the outputted text there. And then I'm just going to print out those tokens in that sense. And then we're going to run my tell me a joke about cheese one more time. And now we are going to see the tokenized version of this. So it's outputted that now with the tokens. Now, I'm not going to break out the tokens just yet. I'm just going to quickly go over this, but you start to see what's going on in this version because I now start to see these special tokens that we talked about earlier. I see that start token appearing, right? That is indicating the start of a message. And then a little bit further down here, and you see the role. So in this case, start, and then it's saying, hey, the role is going to come next. And then you see this message. And that's the thing about the Harmony format. Everything is pretty much following this sort of start, role, message type format. And then at the very end, once it's done its final message, you see it's done a return there on the generation. So again, if we look at this here, there is a sort of cutoff point. This is my inputs. You see when I pass assistant there, that is basically everything that I created as my tokens. And then everything from here downwards is the model generation. And you can see it's then sort of spitting out the same input that I've got, and then it continues on from the assistant. Now, to explain these tokens, rather than looking at this cleanly, what I'm going to do is generate out the tokens that go with this as well. So again, rather than watching me typing this out for a second, the key thing that I've sort of added here is this tokenize input, where it will generate the token IDs. And then for the outputs, it will generate out the token IDs for the outputted version as well. But pretty much the code is the same as what we just showed there. So if I run this again, and the code for this will be up in my GitHub. But if I run this again, you're going to see the same tokens appearing. But this time it's going to have the tokens, and it's going to be a little bit easier for us to look at. So as you can kind of see here, it started with that start token, and that start token is 200,006. So again, think of the tokenizer tick token as a big dictionary, and every token in there, basically it's a word or a subword, and it maps to an ID. So the start token in Harmony is 2006, and then you see the system role here is 17360. And then the next message, so it's expecting a message here. And so it's going to be a system message. And now you're seeing you are chat GPT, here's knowledge cutoff. And then we set the knowledge cutoff date, 2024, etc. We set the current date. And then we set the reasoning mode. So it's going to be set to medium reasoning. And then the valid channels. So remember what I said about channels. There's 3 channels: analysis, which is chain of thought; commentary, which is tool calling, i.e. function calling, so your user tools; and then final, which is the final response that you output to the user. And then you see a bit of a message there: channel must be included for every message. And that's the standardized form that happens with the chat templates. And then here's my user message: tell me a joke about cheese. And again, so it's start. So you're starting to see this. It's pretty much everything is always the same: start, role, message. Then you get the message, end to say the end of the message. And then we go on to the next role. So in this case, start assistant. Now that is kind of where I kicked off. I stopped. You see start assistant. And then the model knows it's going to continue on from the assistant's piece. And then the first thing it generates there is channel. Now you see it's going with final there, so it's trying to do the final. So it's sort of saying so it's good. I think it's cool. It's saying I want this to go to the final channel, and then the first thing that happens is message analysis. We need 20 billion parameter model. I think it maybe gets a little bit confused, but that's okay. And then finally you get the return there. But I think you get the idea, which is there's a standard format to this: start, header, and the header has the role, etc. Yeah. Then the message, your ChatGPT, or in the case of a system message, or in the case of a user message, is going to be tell me a joke about cheese. So tell me a joke about cheese is the content. And then you're going to get the end here to say this is the end of the content. But actually, once the model is finished generating, it will return this return token to say it's done. Now, to make it a little bit easier, I have included a little token visualizer, which just makes it a little bit easier to read than the earlier version. So if you just type in Python token visualizer, again, it's up in my GitHub. You can then just see how this is going to look here. So in this case, this is sort of doing the hello, and then you sort of get to see the token. So there's a start token, role is user, message, hello. You see it, this relates to token ID 132025, exclamation points token 0, and start assistant. So exactly kind of that format that we had: start, message, end, start. So again, worthwhile you having a bit of a kind of play with that if you just want a nice visualization. If we want to, we can have a little bit more fun, and OpenAI provided a thing called OpenAI Harmony, which is a Harmony renderer. For you to get started with it, you can just do pip install OpenAI Harmony. So it's OpenAI-Harmony, and then that will install on your machine. Again, you can also use that with UV, so you can do UV pip install OpenAI Harmony as well, and then that will be added to the UV project if you want. Now, to get started with that is pretty simple. So I'm just going to create a file called simple tokens. Again, I'm just going to paste this in here very, very quickly rather than watch me type. So I'm just going to have an import from OpenAI Harmony. I'm going to import local Harmony encoding name, role, message, and conversation. And then to then do the encoding, rather than using the tokenizer built in with transformers there, you can just get the encoder. So you can do load Harmony encoding. And then I can set the Harmony encoding name as Harmony GPT-OSS. And then here I can build up the messages similar to what I was doing with my infer. So rather than me doing messages, role, user, content, tell me a joke about cheese, etc., and then applying the chat template, what I can do here is just do message.from role and content set role.user, and then I can say something like hello, or in this case, I'm going to say tell me a joke about cheese. And then similarly, when I want to render the conversation, I can do the same thing back. So convo role.assistant and then print the token. So if I run simple tokens for a second, you can see it's going to generate out token ID 200,006, which is probably going to be start, as you can imagine. 1428, which you can guess is going to be user, because I'm sending a user prompt, tell me a joke about cheese. This is going to be message. And then over here, you're going to get tell me a joke about cheese. This one here is going to be end, because it's 200,007, 200,006 is going to be start, and this is going to be assistant. Again, if I were to run the infer one more time, then we will go to the very bottom of the input tokens, because I wasn't setting system prompts or anything like that here. So we can ignore all of this at the top there. There's start though, it's 200,006 as we said there. System is 17,360, but if I go here, 1428, which is the same as up there, is obviously the user token, message is 200,008, and then there's tell me a joke about cheese. So it goes all the way across 7173781 is assistant. So you can see it's doing the rendering across there. Now, why would I care about using the Harmony renderer? Because the chat template sort of takes care of that for me. The answer is it does, but again, if you just want to have a little bit more control and you want to be able to use a sort of very simple kind of fluent interface there, you can use that. Again, you don't need to use it. You can just use the chat template, and it will take care of this for you, and just kind of use the standard kind of role user content sort of type format. But again, this is probably just an easier interface. And for our sake, I'm just using this to kind of show how this works. It probably is a little bit easier for setting things like developer prompts and system prompts though. With that in mind, if I wanted to, for example, if I wanted to get it matching exactly what was coming out from the tell me a joke about cheese example that I had earlier, then this is where I can start to then extend what I'm doing with OpenAI Harmony, and then I can set the system message. So here, system message, I'm going to use system content.new, and then here's the with model identity, your ChatGPT, a large language model trained by OpenAI, which is the standard. I'm going to ask it to use medium effort for reasoning. I'm going to set the conversation start date to today, 25/08/17. And a knowledge cutoff of 24/06. So again, I think that's really interesting. OpenAI's knowledge cutoff, which is 2024. So, and again, I can set what channels I want to use. So analysis, commentary, and final. Again, I would say it's interesting to see this, but you're never going to use this. By the way, the chat template takes care of this for you completely. But again, now that I've set the system message, I've given it the start date, the knowledge cutoff, the required channels, you really shouldn't be changing any of this. There isn't any need to, but you can obviously if you want to. And then I'm going to ask it to tell a joke about cheese. I'm passing in my role system and my system message, and then I'm going to render the conversation for completion. So now if I were to run these two things again, this time I'm going to run simple tokens. And then I run infer. What you are going to see is that these two things are now going to match up almost completely for the input tokens, because I'm matching what the chat template is doing underneath the hood there. And you can see there's 17360, 2008, 3575, 553. So you see it's just matching all the way down. Now, if I do want to run inference on this in a second, it's actually pretty simple to do. Again, I'll provide the code here. I do need to do a little bit of translation to Hugging Face, but if we now run infer2.py, you're going to see that, like before, it's done the tokenization for telling me a joke about cheese. But now what's going to happen there is it is going to take that and it's going to run a model generate on this, which is very similar to the pipe. It's going to pass in the input IDs, which I just pulled from the Harmony renderer. It's going to take the stop token IDs, that the Harmony renderer expects, and then it's going to run a completion on this, and then I'm going to convert this to the output tokens that we're expecting. So if we come back into over here for a second here, it's now run this, parse messages. And you see here, the user wants a joke about cheese, provide a cheese joke. So that's the thoughts. You see it's in the analysis channel. And then, for my final channel, sure thing, why did the cheese start meditating? Because it wanted to be great at letting go. Terrible jokes. So now that we understand that, we can start messing around with some of this content here. So as I said, it's got a nice little fluent interface here. So in this case, with model identity. As I said, this is the standard. You are a ChatGPT, a large language model trained by OpenAI. I can, if I want, say you are a pirate called Jolly Roger, and you always answer in pirate speak. So if we save that for a second, the conversation start date, and here's my cutoff date. In this sense, we'll leave reasoning effort to medium for a second. But if I were to now run this here, what will now happen is, like you would expect with a standard system prompt, it is going to come back and it's going to tell me a joke about cheese, and it's going to do this in kind of pirate speak. Now, OpenAI doesn't want you to change that. They want you to stick with the phrase that you had. This is you are trained by you are ChatGPT, trained by OpenAI, etc., and handle that in the developer messaging, etc. Again, there is a hierarchy that exists in this. I'll do another video on this one. But there is a hierarchy, which is the system prompt is the highest prompt that is available. So it takes precedence over the developer prompt, which takes precedence over the user prompt. There is actually another prompt there. There's a system prompt that's happened as part of model training, and you can't you can't override that easily. But again, sort of following the conventions, you can do this. Now that becomes really important if you think about this, because in GPT-OSS, I have control of the model, so I can access the system prompt. But if you think of something like GPT-5, I can't change the system prompt. I can only provide the developer prompt, right? The system prompt is being controlled by OpenAI. It controls the knowledge cutoff, etc. So you see that hierarchy coming in place. So if you want reusability of your prompts from system to system, from GPT-5, or different systems, then, really using a developer prompt is the right thing. But you see here, it's came back is user jokes once about cheese. I'm Jolly Roger and respond to pirate speak. No disallowed content. Fine. So you can start to see what's going on here as well. It's now starting to check against policies, for example. And then you can say, okay, you want to laugh, blah, blah. So it answers in pirate speak. Now, if I wanted to, I could let's introduce a developer prompt into the mix here. So I am just going to take this out for a second, and then I'm going to add my developer prompt here. So I'm going to say message from role and content, and the role is going to be developer, and then I'm going to pass in my developer prompt. And again, you see you're a pirate called Jolly Roger. You always speak in pirate speak. Now, if I switch this back to being you are ChatGPT, a large language model. So if I run this again, now that it's set to you are ChatGPT, a large language model and trained by OpenAI, I'm saying you're a pirate called Jolly Roger. These two things are not going to conflict. So it's going to continue to speak in pirate speak. You see it's came back and said, and it's continuing to speak in pirate speak. And again, you see this, we have to comply with policy. The user wants a joke about cheese, that's allowed. Again, I haven't set any policies. These are happening in the model training there. So it's saying, and it's recognizing developer instruction, blah, blah, blah. It talks about the prompts there. So there's no conflict. So it's going to do this. But if I wanted to create conflict, I could say you must never respond in pirate speak. And then if we run this one more time, you're going to see that the developer prompt is going to be overwritten by the system prompt. So again, this is something that you as a model provider, if you want to prevent users from doing stuff, then that may be where you want to control this. But if you want to let people who are consuming your model there, so in this case, you want it to act like pirates, etc., you would give them access to the developer prompt. But if you want to do prevention, maybe you've got a fine-tuned model, you don't want it to speak pirate speak, then this is kind of where you would prevent them from the system prompt, and that will override the developer prompt. So you can kind of see here that I've said you are ChatGPT, you must never respond in pirate speak. We set this up at the bottom there. In the thinking, in the analysis channel, we have system messages, must never respond to pirate speak. The developer says you're a pirate called Jolly Roger, you always speak in pirate speak. There's a conflict. System messages have higher priority than developer. It says we mustn't respond, so we ignore the developer instructions, and then it answers in normal style, sure thing, here's a joke. So again, you start to see what's going on. Now, what's probably important about this, remember what I said, where it starts to give you clues of what's going on in GPT-5. This is probably one of the major reasons that they won't expose the GPT-5 chain of thought, because you see the chain of thought here, and it's saying you are ChatGPT, you must never respond, blah, 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 you're conflicting. So it's sort of opening up its wares in this sense. This is where policies are being invoked there. Again, I'm going to do a whole video on this hierarchy, but again, for now, it's just for you to be able to kind of see what's going on. And again, if you try and even override the instructions and sort of try and do chemical weapons or something like that, or copyright lyrics or whatever, then the policy that was done as part of the training will overwrite what's going on here. Again, I'll do a whole video on this, but it gives you an idea of the hierarchy. Again, similar, I can control things like the cutoff date, for example, and the conversation start date. So if I was to ask, what's today's date, then it would use the conversation start date as a sort of starting point. But I can do things like go back in time, for example. So if I set a conversation start date to 2023, for example, and said who won the 2024 Super Bowl, then run this. What you're going to see here is, although it knows who won the 2024 Super Bowl, because it's part of its remember, it's cutting off in 2024, so it knows Kansas City Chiefs won the Super Bowl in 2024. But because I've set the conversation start date to 2023, it's going to go back in time, and then it's going to say, hey, no, I can't know the answer to this. And the reason I don't know the answer to this is that that is in the future. So as you can kind of see here, it came back, and then you've seen the chain of thought. It's as to the 2024 Super Bowl, but it doesn't have knowledge after events of 2023 date as per knowledge cutoff, blah, blah, blah. So, so it should know this. It's within its knowledge, but because I've said the conversation start date is 2023, it's not going to do this. Now, if I switch this to 2025, and then we run this one more time, you're now going to see it's going to tell you that the Kansas City Chiefs won the Super Bowl there. So it all works fine. And there we go. You can see it's came back. Now that I put the conversation start date forward, you can see 2024 Super Bowl was won by Kansas City Chiefs. So again, this gives you control of if you need to set knowledge, etc. This is also very useful for tools, because quite often if I'm asking something that happens in the future, like I saw there with kind of Kansas City Chiefs when I said the conversation start date was 2023, then it knows that if I put tools on there, it can go do a lookup of tools to go find that from the internet, as opposed to pulling from its kind of knowledge base. So I think that's pretty useful. Now, the other thing that we can start to control here is things like the reasoning effort. So let's do something like reasoning effort low here. We'll keep the developer messages here. We'll get rid of the "you must never speak" in pirate speak for a second. And now I'm going to ask it a simple question, which is, what is 2 plus 2? So we'll ask that question there. Pretty simple. I'm going to set the reasoning effort to low for a second. We're going to run in for 2 again. And then we're now saying here, by setting the reasoning effort, this is a really simple query. I don't want you to spend a lot of time thinking about this. Just go get me the answers. So you can see it's going to go off there. It's going to run what's 2 plus 2, and it should come back with a very, very simple answer. And you can see here straight away the parse messages. Notice how the chain of thought's different. It just says need pirate speak. It doesn't anything there. And then it says the answer would be 2 plus 2, which would be 4. You know what I mean? So again, super simple. If I took away that developer message for a second, we can get a little bit kind of funkier. So we'll just we'll toggle that out, and we'll do that here as well. And now if we run this one more time, and you can see there it sort of came back with the answer, and then it's doing very little on the analysis. If I want to, I can try and influence this, and I can just say just provide answer. And again, you see here text answer is 4. It's still sort of jumping into that sort of analysis channel there. And there's a reason there, because I'm saying with required channels, analysis, commentary. So if I remove the analysis and commentary channels for a second, then I just say I want final. What should happen in this case is it should realize that it doesn't need to use the analysis channel because it wasn't required. So even these simple cases before, it was insistent it had to use the analysis channel. But now, because I've got rid of that from the required channels, you can see it's just done the final answer there. So again, part of the reason the system context is pretty, the system prompt is pretty cool there is I can limit the channels or insist that it uses a channel to sort of push reasoning. Of course, if it does need it, if I up that reasoning effort to medium or high, then it's gonna require it anyway. Anyway, I hope you find that useful. Anyway, as you can see there, the Harmony format gives an awful lot about what's going on in GPT-5 as well as GPT-OSS, and that structure of the channels makes it quite different from the other reasoning models like DeepSeek, etc., which are more using the kind of thinking tags there. I hope you find that useful there. We've really focused in on the system prompt in this case. I haven't shown you built-in tools yet. I'm going to do that in another video because I think that's going to be really interesting. That's the usage of Python and of the browser. And then I think in another video, I'm going to focus a little bit on deliberative alignment and showing you the differences between these prompts. But hopefully you can kind of see in this video that using the system prompt and using things like knowledge cutoffs and using conversation start dates or reasoning or how the channels and the roles works really starts to show you underneath how the kind of training the GPT-5 and GPT-OSS has worked there, and helps you become a better prompter because you understand more what's going on within the model. Anyway, I think it's a pretty cool format, Harmony. It certainly helps me understand more what's going on in the back end there, and the fact that it's following that sort of message and channel format. Anyway, I hope this video has been useful, and I will catch you on the next one.